Good evening, sir. You can start now, sir.
Good evening, all. Now the questions. The test 4. We will learn a few questions today and we'll complete the test 4 tomorrow. Now the first question, the compound which is the most acidic. The compound which is most acidic. Now you should remember, acidic nature of the compound is defined using the stability of the conjugate base, which is formed when H+ will be lost from the acid. Now we understand that conjugate acid-base concept. Now we'll take, okay, 1 minute. We will take acid and a base. These all are organic compounds. Now we will take an acid, organic acid, acetic acid. This acetic acid, we know it is a weak acid, but its conjugate base is CH3CO minus. This conjugate base is strong. Now, what is this conjugate acid-base pair? Acid-base pair. Now, we define conjugate acid-base pair as acid-base pair which differ by 1 proton is called as conjugate acid-base pair. Now you can see here it is CH3COH and here CH3CO minus. The difference between these two acid and base is one proton. So acid and base which differ by one proton will be called as conjugate acid-base pair. Now, if the acid is weak, its conjugate base will be strong. If the acid is strong, its conjugate base will be weak. It is reversed. Please remember, if the acid is weak, its conjugate base is strong. If the acid is strong, its conjugate base will be weak. Now, for an example, if you take HCl, HCl is a strong acid. Its conjugate base is Cl minus. The Cl minus will be weak, and HCl is a strong acid. Now, the question here is, compound which is among the compound which is the most acidic in nature. Now you can understand that this all does not contain a carboxylic acid. None of the molecule contains COOH. So no molecule is an acid here. But they have acidic nature here. So the most acidic nature will be based on its conjugate base. Now fluorine atoms are there. You can see in the third molecule, these fluorine atoms are there. So in this molecule, one of the hydrogen atom also will be here, CH2, this carbon and hydrogen here. So this hydrogen will be lost and its conjugate becomes, conjugate acid becomes weak. Therefore, this acid will be the strongest amongst all the other three. Therefore, the option for this question is answer 3. This is concept based on conjugate acid-base pair. The compound that are aromatic among the following are, see, these all are organic molecules. We have to find out which of the compounds are aromatic in nature. Aromatic nature is must have, the molecule should follow 3 criteria. One is it should follow Debye-Huckel's rule. Debye-Huckel's. This Debye-Huckel's rule is otherwise called as 4n plus 2 pi electrons rule. That's called as Debye-Huckel rules. Any molecule which has 4n plus 2 pi electrons, then it's called as Debye. Then it follows Debye-Huckel's rule, and the molecule will be said to be aromatic. Second one is the molecule should be having sp2 hybridization. And the third molecule should be planar. The molecule should be planar. So if these 3 criteria are satisfied, then we can say the molecule is aromatic. The first molecule given here is this, and it is plus. And this is represented as P. This contains only 1 pi bond. Since it contains 1 pi bond, we know that it has 2 pi electrons. It will have 2 pi electrons. Now just see Debye-Huckel's rule. 4n plus 2 pi electrons. If n is equal to 0, what happens? 4 into 0 is 0 plus 2 pi electrons. If a molecule has 2 pi electrons, then it is aromatic. If n is 1, then this n stands for integers. It's not number of carbon atoms. Do not get confused. If n is 1, then you'll have 4 into 1 is 4, 4 plus 2 is 6. So 6 pi electrons. If a molecule contains 6 pi electrons, then it is also aromatic. If n is equal to 2, 2 into 4 is 8, 8 plus 2 is 10. So if a molecule contains 10 pi electrons, then it is aromatic. So the first molecule contains 2 pi electrons, which is following Debye-Huckel's rule. Therefore, this is aromatic. Now coming to the next molecule, we have a heterocyclic ring here. We have this, we have an oxygen, we have a minus sign, and we have a plus sign. This is molecule Q, and it has 2 pi bonds. Therefore, it has 4 pi electrons. Since it has 4 pi electrons, it is not following Debye-Huckel's rule. Therefore, this will not be aromatic. This will not be aromatic. just give me one moment in time. So the second molecule is not aromatic. The third molecule is this. A double bond here, a double bond here, and also a double bond here. This is represented as R. Now, if you observe this molecule, it also has 6 pi electrons. It follows de-Broglie rule, no doubt about it. But you can see this carbon here does not have any double bond. This carbon is sp3 hybridized. Since this carbon is sp3 hybridized, the condition, the molecule should be sp2 hybridized. But here it's sp3. Therefore, this also is not aromatic. The last molecule represented here is this. So you have a double bond here, 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 double bond here. So if you observe this molecule, this is represented as S. We have 1, 2, 3, 4, 5, 6, and 7. 7 pi bonds we have. That means it has 14 pi electrons. If n is equal to 3, so what happens according to de-Broglie rule? 4 into 3 is 12, 12 plus 2 is 14. So if a molecule contains 14 pi electrons, then it will be aromatic. This is aromatic. See, all the carbon atom is sp2 hybridized. It is a planar molecule, and it also contains 14 pi electrons. Therefore, P and S are aromatic. Hence, the answer for this question is option 4. So if a molecule, organic molecule, or compound should be aromatic, it should follow de-Broglie rule. Carbon atom should be sp2 hybridized, and the molecule should be planar. These are the conditions. Next question. The half time of a zero order reaction, A giving you P, is given by K is a rate constant. K is a rate constant. The half time of a zero order reaction, A giving you P. So it is half-life period. Half time, otherwise half-life period. T half for a zero order reaction is given by the formula. Concentration, initial concentration, A naught by 2K. K is the rate constant. This is the relation. T half is equal to A naught by 2K. Hence, the answer for this question is option 1. The first option is right. This is a direct question. So this derivation we have done in the classes. The fourth question. A radioisotope, argon-41, initially decays at the rate 34,500 disintegrations per minute. The decay rate falls to 21,500 disintegrations per minute after 75 minutes. Then the half-life period for argon-41 is. Now, the disintegration, 34,500 disintegration. Well, this is based on radiochemistry or nuclear chemistry, which we do not have in the new syllabus, but you can remember half-life period questions, so we can write. So 34,500 disintegration. So R naught will be initial concentration, e to the power minus lambda t. Likewise, the second condition, 21,500 disintegration, that will be equal to R naught e to the power minus lambda. Time is after 75 minutes. That means it is t plus 75. P plus 75. So on simplification, this will get cancelled. And on simplification for lambda, the value we get is lambda 0.00649 per minute. 0.00649 per minute. Therefore, we know that half-life period of a first order reaction is given by the formula 0.693 by K. Here, in case of nuclear chemistry, instead of K, they use lambda. So 0.693 by lambda. So lambda will be equal to 0.69, TF will be equal to 0.693 by 0.00649. That will be equal to 106.7 minutes approximated to 110 minutes. The closest answer is 110. So do not sometime expect the correct answer. The correct answer is 106.7 minutes. But here, the closest answer is expected for you to answer. So the closest is 110 minutes. The next question. Analyze the below given unit cell. How many atoms are present per unit cell? Analyze the given unit cell. How many atoms are present? Now, if you can identify very clearly, see, these are our corner atoms. These are our corner. Maybe I'll use a different color so that you can understand. Right. This is corner. This is a corner atom. Wait. See, this is a corner atom. This is a corner. This is corner. This is corner. 8 corners we have. A cube will have 8 corners. And you can observe this very carefully. There is a sphere at the center. When there is a sphere at the center, we can write it like this. A cube. There's a particle at the center, and there is a particles at the corners. 8 corners. 8 corners. Like this. So this is a body-centered cubic lattice. Body-centered cubic lattice. So for a body-centered cubic lattice, 8 corner atoms we have. Contribution is 1 by 8. Plus, we have 1 atom at the center. Contribution is 1. Therefore, number of total particles is 2. The answer for this question is option 2. You should identify the crystal. The crystal is body-centered cubic lattice. The next question. What is the coordination number of AAA type and AB type 2-dimensional closed packing respectively? In case of AAA type, the molecules will be in this format. One of the molecule will be touching 4 other molecules. So when one of the molecules touching 4 other molecules, then the structure looks like this, a square. This is an atom in the reference, so it is square. Therefore, the number of coordination number in case of AAA type is 4. Tetrahedral void, it's called as tetrahedral void. Now coming to AB type, it will be octahedral. Now, when we say octahedral, a sphere will be in contact with 6 other cubes, 6 other particles. When it says it is in contact with 6 other particles, you will have a hexagon structure. You will have a hexagon like this. You will identify better. So you will have different color, hexagon, 6 points. You can see 6 particles will be in contact with a particle center reference. Therefore, the coordination number in AB type is 6. So therefore, the correct answer is option B, 4 and 6. By chance, if you write 6 and 4 is also wrong. It is 4 and 6. First one is a tetrahedral void. The second one is octahedral void. The amalgam of mercury in sodium is an example for solid in solid solution, solid in liquid solution, liquid in solid solution, gas in solid solution. We know that mercury is a metal which is in liquid state at room temperature. And we know that sodium is a solid. So therefore, it will be an example for liquid in solid solution. Liquid in solid solution. Okay. Therefore, the answer for this question is option 3. The 8th question. Which of the following reacts gently with water? Lithium, sodium, potassium, and rubidium. We know that sodium reacts violently, liberating hydrogen gas. Similarly, potassium and rubidium also reacts violently with water. But lithium, having the greatest ionization, lithium is small. Since lithium is small, it has the greatest ionization potential or ionization energy. Among all these, therefore, the reactivity of lithium with water will be gentle or mild. Hence, the answer for this question is lithium. So lithium does not react violently with water because it has greatest ionization potential. What is the mole fraction of a solute in 2 molar aqueous solution? What is the mole fraction of a solute in a 2 molar, it is small letter M, it is molar, M-O-L-A-L, molar aqueous solution. What is the mole fraction of a solute in 2 molar aqueous solution? So number of moles we can conclude is number of moles we can conclude is 2 moles. Since we have 2 moles. And since it is molality, water is taken as 1 kg. 1 kg is equal to 1000 grams. So therefore, number of moles of water will be 1000 divided by 18. Molecular mass of water is 18. So what happens is that it will be 55.5. Now, what is the mole fraction of the solute? Mole fraction of the solute will be equal to number of moles of solute is 2 divided by 55.5 plus 2. That is 2 divided by 57.5. So that on simplification, we will get the answer to be 0.035. Hence, the answer for this question is option 2. They have not given you the number of moles of solvent here, but it is aqueous solution. Aqueous refers to water. So therefore, in case of molality, it is 1 kg of water. 1 kg is 1000 grams. So number of moles in 1000 grams is 1000 by 80. That's 55.5. So mole fraction is number of moles of a particular component divided by total number of moles. The standard electrode potential value of metals is given below. Aluminium E0 value is minus 1.66. Silver, it is 0.80, and potassium, it is minus 2.93, and chromium, it is minus 0.74. The correct decreasing order of their oxidizing power of the metal. Now, you should remember a term called as electrochemical series. Electrochemical series. This electrochemical series is also called as activity series. Now, for an example, we'll write now potassium, K, giving you K plus, the electrode potential. This is electrode, and this is electrode potential E0. So it's minus 2.93. Aluminium, Al3 plus. it's minus 1.66. We have zinc 2 plus, that's minus 0.76. I have iron electrode, Fe 2 plus, it's minus 0.44. We have hydrogen electrode. The potential is assumed to be 0 volts. Now we have chromium, they're mentioned here, right? So chromium, I should write here. This part will be chromium here. This will be chromium. So chromium electrode has the potential minus 0.74 volts. And now we have one electrode, maybe copper. Copper electrode will have potential 0.34 plus 0.34, and silver has Ag plus 0.80 volt. Now this electrochemical series is arrangement of electrode in the increasing order of their electrode potential is called as electrochemical series. Electrochemical series means arrangement of electrodes in the increasing order of their electrode potential. You can see minus 2.93 is the least and plus 8.0 is the highest. So arrangement of electrode, only few I remember, and here 4 they have given that I've used to explain what's electrochemical series. Now, in the electrochemical series, you should remember hydrogen will be at the center because its potential is taken as 0. The electrodes which are present above hydrogen electrode, they are all called as good reducing agent. Why they are good reducing agent? Because they will undergo oxidation. Since they undergo oxidation easily, they are called as a good reducing agent. Now, all the electrode which is below hydrogen, they are all called as good oxidizing agent. Why they are called as good oxidizing agent? They undergo reduction easily. Now, the question is the correct order of oxidizing power. What is the correct order of oxidizing power amongst this? Now, this will undergo reducing agents. These all are oxidizing agent. Now, looking at the 4 electrodes they've given, higher potential for silver, it will undergo reduction easily. So when it undergoes reduction easily, it means it has highest oxidizing power. So silver will undergo more reduction easily compared to chromium, compared to aluminum, compared to potassium. Therefore, the answer for this question is option 1. The next question, what is the structure of xenon hexafluoride? Xenon hexafluoride will have distorted octahedral structure. Now, if we write octahedral structure, we can write this as fluorine. We have a fluorine here, and you have fluorine here, and also we have fluorine here. This is octahedral structure. So these 4 fluorines are in one plane, one fluorine atom on the above the other. But what happens is, now this xenon also has a lone pair of electrons. Since it has one lone pair of electron, and fluorine is electronegative, electrons are also negative, there will be distortion. Instead of fluorine being here, it will be distorted. Distorted means moved, disturbed. So what will happen is the fluorine will move like this. From its original position, it will move away. This is called as distorted octahedral structure. So this XeF6 has 6 bond pair of electrons and 1 lone pair of electron. See, 6 bond pair of 6 bonds are there and 1 lone pair of electron. Therefore, they have distorted octahedral structure. The next one, the magnetic moment of certain octahedral cobalt complex is 4.0 Bohr magneton. The electronic configuration is. Now it is cobalt 2, octahedral. Magnetic moment is 4.0 Bohr magneton. We know that cobalt atomic number is 27. The electronic configuration is argon configuration 4s2 and 3d7. Since cobalt, they have mentioned it is 2 plus oxidation state, this 4s electrons will be removed. Therefore, we will have argon configuration and 3d7. Now, this question is based on So you can see T2G, EG, all this. This question is based on crystal field theory. So d orbital, if degenerated d orbital, 5 d orbitals, we will have 7 electrons are there. 1, 2, 3, 4, 5, 6, and 7. Now this is based on energy. When ligands approach that, they get energized and still their degeneracy is maintained. 1, 2, 3, 4, 5, 6, and 7. Degeneracy is maintained. But when the ligands approach them, what happens is they undergo splitting. They undergo splitting into T2G and EG. So here we'll have 3 orbitals and here it's 2. Now totally we have 7 electrons. So when we have 7 electrons, and you can see the magnetic moment is 4. So mu, they've given it as 4. So mu is equal to square root of n into n plus 2. So 4 is equal to square root of n into n plus 2. So we should determine the number of unpaired electrons. Now what happens is, now the n value should be, I think n value should be 2 here. So since we have 7 electrons, we can write 1, 2, 3, 4, 5, 6, and 7. 6 and 7. So you will have T2G5 and EG2 configuration. So 5 electrons in T2G level and 2 electrons in EG level. Therefore, the answer for this is high spin complex. High spin complex is possible whenever the ligand is weak ligand. When ligand is weak ligand, pairing will not take place. Splitting energy will be less. Therefore, what happens? 3 gets filled up here, 4th and 5th goes to the EG. Next, the 6th and the 7th gets paired up. So therefore, the electronic configuration becomes T2G5 and EG2. Next question. When copper sulfate is electrolyzed using platinum electrode, copper is liberated at cathode, oxygen at anode, sulfur at anode. Sulfur cannot get liberated. So copper sulfate is CuSO4. It will dissociate in water to form Cu2 plus and SO4 2 minus. At anode and at cathode, anode is a positive electron. At cathode, reduction takes place. So this copper ions will move towards cathode and it gets reduced and gets deposited as. But at anode, what happens is, this is aqueous solution. Since it is aqueous solution, we also have water. So at anode, water we can write as H and OH minus. H plus and OH minus. This OH minus ions move towards anode. There it will get oxidized. There it gets oxidized, liberating oxygen gas. Water is formed and oxygen gas gets liberated. Remember, sulfate salts, aqueous sulfate salts, whenever we electrolyze, the metal will get deposited at cathode. Oxygen gas will get liberated at anode. Hence, the answer for this question is option 2. The next one. 5A plus 2B, giving you 2B, the rate of a reaction is D, change in concentration of B with respect to dt is equal to. Now they've given 5A, giving you 2B. If you write rate, reaction rate in stoichiometry, for this we can write R is equal to minus 1 by 5, change in concentration of A with respect to time. That will be equal to, this is a product. So therefore, we write plus, the coefficient is 2, divided by 2, change in concentration of B with respect to time. Now they have asked this. So therefore, change in concentration of B with respect to time will be equal to this. If I take it to the left side, it will be 2 by 5 minus 2 by 5, change in concentration of A with respect to time. So therefore, the answer for this question is option 2, minus 2 by 5. Concentration of A with respect to time. So this is what So this is the question from chemical kinetics chapter. The next question, choose the incorrect statement. The incorrect statement, the high value of ionization enthalpy is associated with noble gas. Yes, noble gases are highly stable. Ionization enthalpy is highest. Enthalpy changes associated with electron attachment of the first and the second electron is exothermic and endothermic respectively. The enthalpy change associated with electron attachment of the first and second electron is exothermic and endothermic. That is also right. In lithium atom, the outer electron occupies 2s orbital rather than 2p orbital. In lithium atom, outer electron occupies a 2s orbital rather than 2p orbital. Lithium atom, the outer electron, lithium atomic number is 3. So the electronic configuration 1s2, 2s1. So 2s orbital rather than 2p. That is also right. The valence electron and core electron mean the same. So valence electron means outer electrons, outer orbital electrons. Core electrons will be inner orbital electrons. Therefore, it does not mean the same. Therefore, this is an incorrect statement. Answer is 4. They're asking, choose the incorrect statement. The next question, which of the following quantities are altered by addition of catalyst during a chemical reaction? Which of the following quantities are altered by addition of a catalyst during a chemical reaction? Enthalpy, entropy, activation energy, internal energy. It is truly activation energy. If you take the rate of the reaction with respect to the reaction coordinate or reaction path, reaction coordinate or reaction path, this is reactants and this is products. Now, in the absence of a catalyst, it requires more amount of activation energy, EA. But the same reaction when we perform in the presence of a catalyst, what happens? It takes a different path by reducing the energy of activation. This is in the presence of catalyst. The presence of catalyst, and this is in the absence of catalyst. So in the absence of catalyst, energy of activation is high. In the presence of catalyst, energy of activation is decreased. Therefore, the only thing altered in the presence of catalyst is energy of activation. Option 3. The next question, which of the following metal oxide cannot be reduced to metal by carbon? Which of the following metal oxides cannot be reduced to metal by carbon? Now, aluminum oxide, Al2O3. This aluminum oxide, even though carbon is a very good reducing agent and it's abundantly available and it is cheaper, it reduces most of the metal oxides to metals. But here, in case of aluminum oxide, if you reduce it using carbon, we get aluminum carbide. We will not get aluminum, we get aluminum carbide. That means carbon cannot behave as a reducing agent for aluminum oxide. All these other oxides, lead oxide, PbO2, plus carbon gives you lead plus carbon monoxide. This is reduction. So likewise, zinc oxide, ZnO plus carbon. So we get zinc and carbon monoxide. Here the charge on lead is +4, here the charge on lead is 0, reduction. Charge on aluminum is +2, here charge on aluminum, zinc is 0. So therefore it's also reduction. Similarly with iron oxide also, Fe2O3. This iron oxide, when you reduce using carbon, we get 3 moles of carbon monoxide and we get iron. So only aluminum oxide cannot be reduced using carbon because it forms aluminum carbide. Answer for this question is option 1. Not only aluminum oxide, likewise chromium oxide also cannot be reduced. Manganese dioxide also cannot be reduced by carbon. So in order to reduce chromium oxide and manganese dioxide, they use aluminum as a reducing agent. When aluminum is used as a reducing agent, it is called as aluminothermite process. It will be called as aluminothermite process. The next question. The extraction of gold and silver is done by leaching with cyanide oil. Final recovery of silver is done by distillation, zone refining, displacement with zinc liquation. This question is based on hydrometallurgy. Extraction of metal in aqueous medium is called as hydrometallurgy. If we take silver and gold, we will take metal as in general M. M stands for metal. Metals are always solid. When it is treated with cyanide, but with solution, in the presence of oxygen, we get a complex. We get a complex like this. We get a complex like this too. This is in solution state. This complex which is in solution state, this complex which is in solution state, MCN 2 times, plus if you use a reducing agent as zinc, which is a solid, we get ZnCN4 2 minus, plus we will get O4 OH minus, and we get 2 metals. So here the charge, this is a metal. This is silver. We will get, this is the ore of the metal, and this is the pure metal. So in order to extraction of gold and silver is done by leaching with cyanide oil. The final recovery is done by displacement with zinc. Hence the answer for this question is option 3. The next question, read the given statements. The symmetrical electron distribution renders the bond of diatomic molecule non-polar. The electric dipole moment of NH3 and NF3 is equal. The dipole moment of polyatomic molecule is the resultant of all the electric dipole of the bond. Choose the correct option. Choose the correct option. Now, in case of ammonia, ammonia has a pyramidal shape like this. It has one unpaired electron. And you can remember nitrogen is electron withdrawing group here, highly electronegative. But if you take fluorine, NF3, fluorine is highly electronegative. Even though we have, so resultant will be, the dipole moment will be like this for ammonia, resultant. But in case of NF3, it will be cancelled. This portion will be like this and this will be like this. Partially it will be cancelled. Therefore, dipole moment of ammonia and nitrogen trifluoride will not be same. Hence, the incorrect statement is this. The other two statements are right. Hence, the answer for this question is option 3, A and C. The next question, the enzyme which decomposes urea into ammonia and carbon dioxide is called as maltase, urease, zymase, pepsin. So urea is NH2, CO, NH2. Aqueous urea and water. In the presence of enzyme urease, it decomposes to give ammonia and carbon dioxide gas. So urease is the enzyme which decomposes urea to ammonia. Therefore, the answer for this question is option 2. Choose the correct statement. IF5 is polar molecule. IF5 is polar molecule. IF5 is a polar molecule. The first ionization potential of K is lower than that of lithium. They're asking for the correct statement. IF5 is a polar molecule. Why it is polar molecule? Because it this IF5 it will have this structure. This has 5 bond pairs, and it also has a 1 lone pair. 5 bond pair, and it has 1 lone pair of electrons. Therefore, it is a polar molecule. True. First ionization potential of potassium is lower than lithium. Potassium is big, lithium is small. So therefore, ionization energy is removal of an electron from the outermost orbit. So potassium is, since it is bigger, ionization potential is low for potassium. This is also true. Bi3 is trigonal planar, but Pi3 is pyramidal in shape. So Bi3 has only 3 bonded pair of electrons, but Pi3, it has 3 bonded pair of electrons plus 1 lone pair of electrons. Therefore, this is trigonal planar and this is pyramid. So all the 3 answers are right. Hence, the correct option for this is all the above. The next question. The type of d orbital used in the hybrid orbital of trigonal bipyramidal structure is. So dz square is the orbital which is involved because it will form axial bonds. Equatorial bonds, axial bonds, you should remember. So since it forms axial bonds, dz square orbital are used up in hybridization of trigonal bipyramid. Hence, it's option 4. 1 minute. Choose the correct statement. Sterling silver is an example for substitutional alloy. Carbon steel is an example for interstitial alloy. Brass is an example for intermetallic alloy. All the 3 are right. So the correct answer is all the above. Pumice stone is a colloidal solution of gas and solid, gas and gas, liquid and gas, gas and liquid. So pumice stone is a colloidal solution of gas in a solid. Option 1. The next question. In which of the following compounds nitrogen exhibits fractional oxidation state? Nitrogen exhibits fractional oxidation state. Now azides. In azides, normally, in azides, nitrogen will exhibit -1/3 oxidation state. So only in hydrogen azides, nitrogen will have -1/3 oxidation state. Hence, the answer for this question is option B. Next question. Which of the following oxides of nitrogen is blue and acidic solid? NO2, N2O3, N2O, and N2O5. Which of the following oxides of nitrogen is blue and acidic? So it is option 2. It is N2O3. N2O3 is blue and it's acidic and it's solid. Dinitrogen trioxide. Calculate spin-only magnetic moment of chromium 3+ ion in Bohr magneton. So magnetic moment is given by the form representation mu. Mu is equal to square root of n into n+2. Chromium atomic number is 24. The electronic configuration is argon configuration 4s1 and 3d5. If we take chromium 2+, the configuration is argon configuration. 1s electron from here and 1 from here will be removed. So it will be argon configuration and 3d4. Since it has 4 unpaired electrons, well, the magnetic moment will be square root of 4 into 4 plus 2. That is square root of 4 into 6. 4, 6, it will be 24. So the answer, root 24, will be around 4. No, it's not 4.9. Root 24. Yeah, root 25 is 5. Root 24 will be close to 5. It's 4.904 magneton. Hence, the answer for this is option B. The next set of questions, we will learn from tomorrow. We'll learn tomorrow. Because 28 questions, if we finish tomorrow, we'll have less number of questions. So we'll do it tomorrow from 28th. Thank you. Ma'am, I'm stopping the class, ma'am. Ma'am? Ma'am?
Thank you.
Yeah, bye.